Good morning, students. Welcome back to chemistry class. Okay, today we are going to see the continuation of the last class. Today we are going to see the continuation of the last class, that is solution. Last class what we studied, solution has been classification of solution, isn't it? On the basis of the size of the solute, it is classified into true solution, colloidal solution and suspension. What are they? True solution, colloidal solution and suspension. So what is true solution? True solution is a homogeneous mixture. True solution is what? Homogeneous mixture. Remaining what? Both are heterogeneous mixture. And suspension, it can be, the solid particles can be filtered, so it is possible. Colloidal solution, solid particles cannot be filtered, but it can be settled down by using centrifugation technique. I taught you what is centrifugation. Okay, the last one, true solution. Here filtration is also not possible, settle down of the particles also not possible. So the first one is transparent, next one translucent, and the last one is what? Opaque, isn't it? And I mentioned that colloidal solution alone shows Tyndall effect and Brownian movement. Alone shows what? Tyndall effect alone are shown by which solution? Colloidal solution. What is the reason that we can see? So colloidal solution is what type of mixture? Heterogeneous mixture. Size is 10 power minus 7 centimeter to 10 power minus 5 centimeter. What is the size? 10 power minus 7 to 10 power minus 5. Isn't it? Yes or no? So less than 10 power minus 5 means what solution that on? True. Greater than 10 power minus 7 means what type of solution that on? It's a suspension. Okay. And this colloidal solution has two phases. One is dispersed phase and dispersion medium. Okay. Dispersed phase may be of solid liquid gas. Dispersion medium also may be of solid liquid gas. They combine with each other. For example, solid in solid, example alloy. Solid in liquid, example paint. Solid in gas, its example smoke. Like that, liquid in solid, gel. Liquid in liquid, emulsion. Liquid in gas, aerosol. Okay, aerosol or fog. So at any combination, they can combine to form what? Colloidal solution. So some of the examples I have written here, code, smoke, etc. In the smoke, see, smoke means what? It contains carbon particle. It contains what particles? Carbon particles. So it's solid. So dispersed phase and gas is what? Dispersion media. So solid particles that is dispersed over the gas is called as what? Dispersed phase and dispersion medium. Next we can see what is Tyndall effect. So once again I say colloidal solution has two phase, dispersed phase and dispersion medium. So they can combine with each other into any proportion and also any combination. Nearly 8 combination we will get to form colloids. In each has what? Dispersed phase and dispersion media. Here one example I have given here, carbon particles. That is solid particles, that is dispersed over the gas. So dispersed phase and dispersion media. The next one, Tyndall effect. So this was discovered by the scientist Tyndall in the year 1869. So it was discovered by whom? Scientist name what? Tyndall in the year 1869. I have drawn 3 diagrams. Can you see that 3 pictures? True solution, colloidal solution and suspension. So in the true solution, there is no solid particles because less than 10 power minus 5 and it is completely dissolved. Colloidal solution, the particles are spread everywhere, dispersed everywhere. Here, they get settled down. Okay, va? See the difference once again. No solid particles. Solid particles are dispersed over the medium. Here, solid particles get settled down. And now I am sending a beam of light. When the light is passed, isn't it? When the strong beam of light is passed or focused into these 3 types of solution, what we can see. First one, there is no visibility of the light because it's a true solution. So here, there is no visibility of light. Here you can see the light rays, isn't it? The path of the light is visible. Here there is no. Why here means these colloidal particles are a little larger in size comparing to true solution and it capture the light and it scatter the light. So only here you can see the shadow of the beaker and the path of the light is become visible because all the colloidal particles that absorb the light and scatter light. And the path in which you have seen, we can able to see this path is called as Tyndall cone. The path of the light is called as what cone? Tyndall cone. Okay, students. So when a beam of light is passed into the colloidal solution, what happened? The colloidal particles scatter the light and the path of the light become visible. This illuminated path is called as Tyndall cone. In the headlight, the beam of the light that is coming from the headlight, isn't it? Can you see vehicles? Okay, it is the best example for what? Tyndall effect. It's the best example for Tyndall effect. So, Tyndall effect. Who discovered? Tyndall. Here, Tyndall means what? Scattering of light by which particles? Colloidal particles. What is the reason? Because it has dispersion phase and dispersion medium, which is responsible or which is capable of absorbing the light and scattering the light. So we can see the visibility of the beam and also the shadow of the beaker. Whereas these two, they does not possess these properties. Only here we can see this property clearly. That is called as what effect? Tyndall effect. Do you understood what is Tyndall effect? Okay. So this is the true colloidal and this is suspension. Okay, in the home also you can do this. For true solution, you can take salt in water. For colloidal solution, you can take starch in water. Last one, suspension, wheat flour or sand in water and send a beam of light, torch light, and you can see the differences. Okay, students? So, Tyndall effect completed. Next one, Brownian moment. So, it was discovered by whom? Scientist Robert Brown. In his honor only, he named the movement also Brownian movement. Who discovered? Robert Brown. This movement is first observed in pollen grains. So he takes some pollen grains which is present in flower, isn't it? And he dissolved in water and a single drop he kept under the microscope and he viewed under the microscope. At that time he saw the pollen grains were constantly and rapidly moving in a zigzag fashion. This is called a zigzag fashion. This is the pollen grain. When we see, this is the water. Okay, in water, the water molecules or water as a medium, what is present? Pollen grain. When we see under powerful microscope, he saw these were dancing here and there. This movement only he named as zigzag direction. What is the reason? See here, when the pollen grain is here, it was hit by water molecule. So from one direction, it is moving into the next water molecule hit. From here, it is moving here. So it is going on moving due to the unbalanced bombardment of the particles. What particles? That present in the dispersion medium. Here what is the particle? Water. So H2O molecules cause collision or this pollen grain collide with the water molecules. Since only this collide, due to this collision only, these pollen grains are not standing on a position. They are moving here and there like a zigzag fashion. So this is the reason why the colloidal particle shows the Brownian movement, because we know that no solid particles are present in true solution and in suspension everything gets settled down. Only in the colloidal solution colloidal particles are dispersed. So these colloidal particles hit by the components or the particles or the molecules that present in the medium, which makes to move here and there to form zigzag direction. So this is about what? Tyndall effect and Brownian movement. Once again discovered by Robert Brown. First, it was observed in pollen grains, and the movement, unusual movement or rapid and constant movement of the solid particles that are present in the medium is due to the unbalanced bombardment of the particles. That may be a water or any other medium, the particles that are present in the dispersion medium. Okay. So students, it's a very important question. At the last of this video, I will mark all these questions. Okay. The next one. So now we come to the last topic of this lesson, that is emulsion. Last topic of this lesson, what is that? Emulsion. Emulsion comes under colloidal solution. It is one of the colloids. And the word emulsion is taken from the Latin word that means milk. Milk contains fat. Fat does not dissolve in water. So it also a good example for emulsion. And how these emulsions are formed? It is formed of two or more immiscible liquids. That is dispersed phase also liquid, dispersion phase as well as dispersion medium. Dispersion phase also liquid, dispersion medium also liquid. What type of liquid? Immiscible liquids. Last class we studied what is miscible and immiscible. Am I right? Miscible means what? Both the liquids that dissolve with each other. What is the technique that used for separating miscible liquids? Fractional distillation. Isn't it? Distillation or fractional distillation. Isn't it? Do you remember that? Yeah. Next, what is immiscible? That it does not dissolve with each other. Oil in water, kerosene in water are the examples. What's the technique we used for the separating such type of liquids? Do you remember what type of liquids? Yeah, by separating funnel, we can separate such type of liquids. Here, both dispersed phase and medium, both are liquid. What type of liquid does not dissolve with each other? So, example, milk, butter, cream, etc. The facial creams also comes under where? Emulsion. Paint is a good example for what ma? Emulsions. And it is of two types. Two types means here both oil and water, oil and water. What is the difference? See here, oil acts as dispersed phase, that is solute. Here water acts as solute. Here what is more concentration we have taken? Water. Less concentration oil. Here more concentration oil, less concentration water. So two types are there, oil versus water and water versus oil. Example for oil and water is cream and water plus oil is butter. This emulsion plays important role in many industries like pharmaceutical industries. Most of the things that is produced is in the form of emulsions. Most of produced creams, pharmaceuticals industry, most of the product that comes from there is emulsions. Metallurgy, there also we are using what? Emulsions. Most of the product that are coming there is their emulsions. Next one, food processing industry also most of the items are, most of the important role is done by emulsion. So emulsion plays important role in food processing industries, metallurgy, that is extraction of metals, that is called metallurgy. Next one, pharmaceutical industry. So with that we have completed our lesson successfully, students. Next class we will start the next lesson, that is a good interesting lesson, atomic structure. Okay, ma? Now we are going to mark some important questions in your book and we are going to finish this chapter. Shall we see that? Take your books and mark along with me. Book back, Roman number 7, second question. Roman number 7, second question. Brownian movement, Tyndall effect. This and also mark this. This is the answer for this question. So students, another one example also you can see for the Tyndall effect, scattering light or the Brownian movement. At early morning, when we open the window, the sunrise enters the house through the windows. The path of the light is very visible. You can see the rays, isn't it? In this rays, you can see the dust particles dancing here and there. It is moving constantly and rapidly here and there. That's the best example for what? Brownian movement and scattering of light. The dust particles, they scatter the light which is present in the gas, as well as they move constantly here and there due to the collision with the dust particles. Okay, that's the best example. Okay, so now mark this question. Roman number 7, 2. Very, very important question. Tyndall effect and Brownian movement. Next, one more question. This is a book inside question. What are the difference between types of solution? Here more, nearly 7 or 8 points are there. You learn first 5. Very important, often asked question. What is the difference between, or compare the properties of true, colloidal and suspension? This is a common asked question. Compare the properties. You just write compare the properties of true, colloidal and suspension. Learn first 5 points. Okay, ma'am. Then from here it can be asked, this tabular column you have to learn for one word. Book inside one word you have to learn. Page number 120 and 121. Okay, take page number 120 and 121. One 7 mark question over. One book inside 5 mark question over. Then this is the one word. Then underline this. What is emulsion? The meaning for emulsion is milk. What are the two types? Oil versus water and water versus, with the example cream. And next one is butter. Okay, mark this. The next, take this question, Roman number 5, adsorption and absorption. Mark it. Roman number 5, first question, adsorption and absorption. Then the same page, this is a very important book back question. It is on page number 119. 119. Mark this. Students, mark this. Next year, 10th, you have this portion, same portion, solution lesson. You will study very briefly. So there, this is very important 2 mark question. What is solution, what is solute and solvent? So this year itself you learn. This is a very important question, important 2 mark question. Completed? See here. Fractional distillation. Under this fractional distillation, what is the principle? Difference in boiling point less than 25 Kelvin. Fractional distillation is employed if the boiling point is less than 25 Kelvin. where distillation employed when two liquids boiling point differ more than 25 Kelvin. This one, if they ask what is the difference between distillation and fractionation, this is the main point. Here distillation, this is the main point. Two liquids whose boiling point differ more than 25 Kelvin. Here less than 25 Kelvin. Then, okay, underline this. The next, sublimation. It's a book bag question already I have given. Here homogeneous and heterogeneous already we marked, and do this as a homework. Activity 4 as a homework. Sand and water mixture, sand and iron mixture, isn't it? Water and oil mixture. Okay, carbon dioxide, what is that? Compound. Alcohol is a compound, meaning mixture. So this you have to do as a homework. Okay, students, do this as a homework. And at the top, important question is there. Book inside question, difference between mixture and compound. Difference between mixture and compound. This is the book inside question. Mark it and learn. And here one important. What is mixture? This is the answer. Page number 115. This is the answer. What is mixture? And this is the important one word. Mark it. LPG, liquefied petroleum gas. Okay, did you mark it? Now we can see the fill up and book back evaluation part. Okay, take the book back evaluation part. See students, this is the match the following answer. Element, pure substance. Compound, made up of atoms. Colloid, made up of molecules. Suspension, settle down on standing. Mixture, impure substance. Then this is the fill up the blanks. Already I have given once more. Homogeneous, camphor, fractional distillation, difference in solubility. Okay. Then next one, state whether true or false. The first one is true. Second one is false because compound can break, broken down. Here cannot. So cut the knot and write here false. After writing the false, we have to correct the statement. So here you cut the knot. The next one also false. Liquid in liquid forms what? Emulsions. Here gel it is given, isn't it? So you can convert liquid in solid. Cut the liquid and write solid. Here true. Buttermilk is an example for what mixture? Heterogeneous mixture. Aspirin, here it is written mixture. You have to write it as a compound because if they are combining in a fixed proportion. So if the atoms or molecules combine in a fixed proportion, they produce what? New compound. So it is a compound. It's not a mixture. It is a compound. Aspirin is a compound. Okay. Take the next page. Page number 124. Here you write. Here it is asked, oxygen is an element or compound? It is an element. Oxygen is an element made up of same atom. Isn't oxygen gas also? It is an element only made up of same atoms. So element, it is an element. Oxygen is a very essential. Here not mentioned as oxygen gas, it is oxygen. So oxygen is an element. Next one, 22 karat gold. It's not a pure gold. It consists of many 2% is copper. Okay, it's an alloy. So it's a impure substance. 22 karat gold is an alloy. So you can mark it as an impure substance. It is not a pure substance. It's a mixture. That is impure substance. See students, next here one question is asked. How you will separate salt, oil and water? It is the combination of two techniques. One is separating funnel. Next one is evaporation, isn't it? So first we should subject it to separating funnel. By using separating funnel, we can separate oil and water. Then again by the evaporation technique, we can separate common salt from water. So you write it is the combination of two techniques, separating funnel and evaporation. Then here one question is given, how the mixture containing dust, naphthalene ball and iron fillings. How we will separate? Here two method is there. One is sublimation and magnetic separation. Here you write sublimation. Naphthalene, near you write sublimation. Iron fillings, near you write magnetic separation. Naphthalene, sublimation. Okay. So what you have to do means, first we have to what? Does iron fillings, when you bring the iron fillings near, magnet near to the iron fillings, it is get attracted towards it. Now on heating, naphthalene will get evaporized. Remaining what is found? So dust. Okay, students. So with this, we have completed. One or more questions also there. I will give in the next class. So next class, we are going to start the fresh lessons, that is atomic structure. So before that, you have to learn all the question answer whatever I have given today. Okay, and the book inside questions you have to copy down in your notes. Okay, students. Okay, the book inside 5 more questions also you have to learn. Very important question: difference between element and compound, Tyndall effect, Brownian movement, difference between mixture and compound, compare the properties of true solution, colloidal solutions, suspension. Okay, thank you so much.